Okay, so now we're going to talk about one important type of motion, which is uniform motion. This is a motion in which the velocity or the speed don't change. The object is moving at a constant velocity or at a constant speed. So a motion diagram for that type of motion would be something like this, where all the dots are equally spaced. So it is moving the same distance every frame. So that is a motion diagram for uniform motion. Position versus time graph for that type of motion would be a line like this one here. The slope is the same all over. So you have this distance here, the rise. The rise is the same all the time for time points that are equal distance apart in time. So this point and this point, the rise for this point and this point is the same as for this point and this point. And so that is uniform motion is represented by a straight line. So let's look at a little bit more at how to calculate things given information in the problem. For instance, we would like to get the velocity. The velocity would be given the position versus time graph, right? So this is uniform motion, a straight line. This is position. This is time here. So you would need to get the rise over the run, right? So rise over the run, and that'll give you the velocity. And the rise typically is the final position minus the initial position, and the run is the final time minus the initial time. So with this equation here, then I can rewrite this. So let's just do it over here. Vx is equal to x final minus x initial divided by t final minus t initial. So now I'm going to take this and send it to the other side. So I'm going to rewrite this equation as x final minus x initial is equal to Vx times t final minus t initial, right? So if we assume that t initial is 0, we can always assume that for our purposes. Then we can write that x final minus is x initial. And let me just delete this. So we can assume that x final minus x initial is equal to Vx times t. And now I just need t because t final is t initial is 0, and then t would be t final. So then I have this equation here, which is this equation here, and that is our first equation that we need to remember. This is the equation for uniform motion. Another way to write this is that delta x is equal to v times delta t. So the displacement is proportional to the time interval, and the constant of proportionality is delta t. So let's just review quickly what proportional relations are. So we have proportional relationships are represented by straight lines. So if we have a coordinate system, this is your x and this is your y. And now here we're not talking about position or velocity. This is just a variable y and this is a variable x. Then a relationship like this one here, like this red line, is represented by y equals to cx. Remember, this looks y equals to cx looks pretty much like delta x equal to v delta t. It is very similar, right? So we would say that y is proportional to x. We would say here that delta x is proportional to delta t. C, which for our case that all could be the velocity, is the constant of proportionality, the proportionality constant. How do we get that? Well, we would need to get this over this would be the constant of proportionality. So C would be delta y over delta x. And that is also equal to the slope of the graph. So So this is an important type of relation. If you don't remember this, you need to review this. We're going to be using this a lot. So let's look at a simple problem here. We have a position versus graph of an object. So this is the whole motion. You can see the motion is uniform from 0 to 1, then uniform from 1 to 2, and uniform from 2 to 4. It changes from here to here to here, but it is uniform in this segment, and uniform in this segment, and uniform in this segment. So the question is, at t equals 1.5 seconds, which is somewhere here, the object velocity is what? Is 40 meters, 20 meters, 10, minus 10, of none of the above. Why don't you take a minute to answer this question and I come back to the answer? All right, if you have tried, then the velocity, this is a proportionality, this is a proportional relationship. So all I need to do is find the slope here. That would be Vx. The slope is rise over run, right? So this over this. So it would be, the velocity would be 20, which is this rise, over the run, which is 1, which is this run here, and that is 20 meters per second. So that's the velocity, so it would be V. So let's look at a little problem here, right? So a train leaves Cleveland at 2, and then train is moving due west, is moving at a constant speed, and a passenger notes that it takes 10 minutes to go 12 kilometers. How long will it take to travel 60 kilometers? So we have to break this into two parts. So we want to find how long it takes to travel 60 kilometers. So for that we need the velocity. And then the time that it takes to travel 60 kilometers would be t, would be equal to what? Well, let's just remember what the equation for velocity is delta x over delta t. So then delta t, which is the time that it needs to travel some distance, is equal to delta x divided by v. So we need to find the velocity. For that, we know this information here. So we know that v is equal to delta x over delta t, and we are told that delta x is 12 kilometers, delta t is 10 minutes. So then it travels a distance of 1.2 kilometers per minute. So how long does it take to travel 60 kilometers? Well, to travel 60 kilometers, delta t would be equal to 1.2 divided by, I need to use delta t is delta x divided by v, which is what? Is 60 kilometers divided by 1.2, and that is, let's just find a calculator quickly here. So 60 divided by 2 in my calculator here, 60 divided by 1.2, that's equal to 50 minutes. All right, so that's how you would do a quick problem like this. This is a problem that doesn't require much thinking. It's just a uniform motion, and all we need to do is know how to use this equation here, which is equivalent to this equation. My final position is equal to my initial position plus the velocity times the change in time.